traditional orthophoto versus true orthophoto. I will start my first presentation, first point, so traditional versus true orthophoto. So I try to emphasize first that you need to understand, so what's the big difference? And the big difference is that traditional orthophoto is calculated based on digital terrain models. So we do the classification, we eliminate all the houses, buildings, poles, everything out. So we just have a terrain point with a point cloud. We calculate the digital terrain model, and then we do the projection of the drone images or any airborne images on the terrain model. And that's why I try to emphasize this here with a left picture on your screen, so the flat picture where the orthophoto is on, so that you remember always traditional orthophoto is where no buildings are as a models on and everything like that. So it's calculated based on digital terrain model. Opposite side, the true orthophoto is calculated based on 3D model, which we call the textured full 3D mesh. So this is a triangulated surface with the buildings, with all the details which are pointing out of the surface, and then we put texture on this model. It's a fully different calculation, has some benefits, but also some cons in comparison to the traditional orthophoto. But remember please this, so traditional is calculated based on the digital terrain model, true orthophoto is with buildings and everything like that. Okay, and now if we go first traditional orthophoto and see the advantages and disadvantages, we can quickly collect them here. So first I would like to go with the left side with advantages. So the traditional orthophoto is suitable for large areas. So if you have big areas, the complete, I don't know, village or a big construction site, or let's say a big rural area, low growth or anything like that, is the best case example to do it with traditional orthophoto. It's a pretty fast calculation because you need a point cloud, you don't need a full 3D mesh, which takes additional time, and it's also pretty power consuming. So the calculation is it's simpler because of simple algorithms. Third point already, the benefit, it's less hardware demanding. So if you have 3000 image projects or something like that, full 3D mesh, it's kind of hard to calculate it. You probably need to split it in small parts or something like that. But with the traditional orthophoto, you can cover it. Then in traditional orthophoto, yes, you have option to replace an image. So it's a simple feature in 3Dsurvey. For example, if you have road with cars, you can simply select the car areas and replace it with another image, because the moving objects are always on a different location and you can easily replace this part. And the last but not least benefit, the traditional orthophoto give you actually the maximum detail from the input images. So what does it what does it mean? Actually, because the algorithms are simpler, the surface is more flat. When we do the calculation image on a surface, the pixels are nicely visible. So actually, what kind of the image input goes in the calculation, in the orthophoto, you get the same resolution, the same quality. So let's say no artifacts. I will show you this later on a real case example. So we would say you get the maximum detail from the input images with traditional orthophoto. And this is kind of super important if you need to extract out data like end of the road, or I don't know, the center white painted stripes or anything like that, or manholes, so you get really good visibility. But nevertheless, traditional orthophoto has also some disadvantages, and those are at least one image must cover or contain the entire object for best results. So this is mainly going if you have buildings on or bigger holes or anything like that. So if you are able to capture images in this way, that the complete house is on a single image, then the traditional orthophoto will at the end also look nice. Otherwise, you will also have some blurry passes where two images are glued together. Okay, so this is the first negative aspect. Then the second one, on traditional orthophoto, roofs and objects which are pointing out from the surface are not on the correct coordinates. Okay, so this is super important to know. So if you calculate the traditional orthophoto with digital terrain model and you do the vectorization on the roofs in 2D, this is not a good approach, okay? Because roof is definitely not on the right spot. This is the minus of traditional orthophoto. And then the third disadvantages, you need to have nadir images. So where the camera is pointing perfectly down, usually you get this with a single grid mission, which is the most effective way for mapping. You can easily cover large areas, but in case you did a double grid mission with a 45 degrees camera and you would try to calculate traditional orthophoto, this is not going to work, okay? Because the orthophoto will look like mess. So definitely you need to have nadir images to calculate traditional orthophoto. If you did a mapping with nadir images plus oblique images, so side images also, then before you calculate traditional orthophoto, just deselect the oblique images and you will get a nice traditional orthophoto. I will also show you this later on my example. Okay, so much about traditional orthophoto. There are some questions. Feel free to write them in question box, and I will switch to my second orthophoto, true orthophoto. And again, we have some advantages and disadvantages. And advantages of true orthophotos are roof and all other objects are on the correct coordinates. So this is one of the most important one. So if you like to vectorize out the roof positions or objects which are pointing out from the terrain model from the orthophoto, use a true orthophoto because they're on the right coordinates. Then the second benefit, it's a fully automatic workflow. So if you calculate true orthophoto, you can import images, use our batch processing, and from image to orthophoto, you don't need any interactions because you don't need to do the classification in between, which is a manual step. And with the true orthophoto, it just fully automatically everything.
Remember, we just talked about this one on the previous webinar, so you can check that out.
Exactly. Thank you, Mattia. So then the third strong point, when you have the full 3D model with the all nice facade and nice 3D objects, you can easily produce also custom plate or sign orthophoto. So if you have details from the facade, you can turn the bounding box for the side orthophoto and produce a custom plane or side orthophoto. And another benefit, so the true orthophoto supports nadir and oblique images. So even if you have some side images, nadir images and everything together, this is actually perfect for true orthophoto. And in this case, it delivers also the best possible results. We also have few disadvantages for the true orthophoto. And the one is so-called artifacts. So like bulked edges or trees, and this depends actually on mesh quality. So the better the 3D model is, the better the true orthophoto is. But nevertheless, if you zoom in an orthophoto, you will always have a bit better how to say, not just resolution, but visibility with a traditional orthophoto in comparison of true orthophoto. Because algorithm for true orthophoto is more complicated, we need a full 3D mesh and so on. And this is kind of a bit of minus for true orthophoto. And the second one, it's to calculate the true orthophoto is more time consuming, it takes longer time. Beside the point cloud, you also need full textured, full 3D mesh. And if you have big data sets, 3000 plus images, you need a powerful machine that it can take much longer in comparison to the traditional orthophoto. Okay. And as a conclusion with this topic are our guidelines when to use and what's important. So when to use traditional orthophoto or when to use a true orthophoto. And I will go with these general rules. So traditional orthophoto, if you have rural areas, so where fields are, where stockpiles are, where roads are, highways, less buildings, smaller buildings, or something like that, the perfect option is traditional orthophoto. If you have large areas when you can cover few, I don't know, few villages, or let's say even a city or something like that, and you can fly higher, use traditional orthophoto. If you have linear objects like road, highways, railroads, cycling roads, rivers, again, the traditional orthophoto is good enough. And also for stockpiles or open pit mines. So where you don't have some kind of specific buildings, objects, or anything like that, where the terrain is more important for you, the traditional orthophoto covers this very nicely. And what's important with this one? So again, remember, you need to fly for traditional orthophoto, a single grid mission with nadir images. So camera needs to point top down. In a DJI, I think it's a minus 90 degrees or something like that. And in case you have oblique images also from the side, definitely deselect them before you go and calculate traditional orthophoto. Just leave the top-down images. You can do this in an image tab. There is a function to do it, and that's it. And the second important point with traditional orthophoto, fly as high as possible. We recommend between 80 to 150 meters above AGL. Why this is important? The higher you fly, the more orthogonal your image is. So the effect of the side turn of the building will become less important. Okay, so higher you fly, more orthogonal images, more area you cover with a single image. Remember, if you like to get nice traditional orthophoto, you need to get complete building on a single image, otherwise it's not going to look nice. And with flying height on 80 meters with the most standard drone, you can cover, let's say, a 2 centimeter resolution of orthophoto. If you have like P1 camera from DJI, so I think it's on 120 meter or 130 meter 2 centimeter resolution or something like that. And in most use cases, this is more than enough. Okay, very good. This was traditional orthophoto. The next one is true orthophoto. We warmly advise you to use a true orthophoto approach in case you are flying urban area and city centers where mainly high buildings are, big halls, anything like that. So definitely with the traditional orthophoto, you're going to get much worse results in comparison to true orthophoto in this case. Then the second location where we would advise you to do is industrial areas with big holes and long objects. You can cover really nicely this with true orthophoto with minimum artifacts, and of course construction site with buildings. If you already have on a construction site some concrete walls or everything like that, and this is important for you, do the true orthophoto. Okay. So hopefully you get an idea where to use which and what. And what's important for true orthophoto, you need to fly double grid with oblique images. So just remember, the better 3D model, the better true orthophoto is. So make as much images that you can from a different perspective, different positions to get the most beautiful full 3D model, and then parallel, you will also get a nice true orthophoto. And because you are always pointing camera in 45 or 50 camera degree angle, we advise you to fly a bit lower in comparison to the traditional orthophoto. So we would recommend flying height between 40 to 80 meter AGL, that you have more detail in a photo, because if you assume when you point camera down, it's actually 80 meter, when you turn camera a bit up, it's 80 meter flight, 150 of 120 meters or something like that. So that's why fly lower and capture images. Okay, this was with the PowerPoint presentation. I also have a few quick examples to share it with you. Just a second.
Yes, show us some 3D models, Marco.
Okay, so let's go with the video. Here I would like to show you, so a traditional orthophoto example, nice single grid flight with a perpendicular top-down camera. I think 2,500 images with Metris 350 or something like that, and P1 camera. You see, we fly a single grid mission. Actually, this is from one of our customers. Thank you for sharing this with us. And calculating orthophotos, classification. Here we can see the digital terrain model, so no buildings inside, just pure terrain. And if we go to the, okay, let's expect a bit in addition. And if we go to the orthophoto and zoom in inside, because here was actually a flying height 120 or 150 meters, actually a lot of information will cover it in a single image, and that's why the most problematic areas on hose areas, hole areas, everything like that looks actually really good with minimum artifacts. Here we can see the cars on the road. We could use the recalculation option and eliminate those ones. Now I would like to focus on a bit more problematic areas. So here you can see the object is not perfectly perpendicular. It's a bit from the side. We see the bit of the facade on, but nevertheless, this is kind of rural area with not too many big buildings. Okay, we have some holes here, and this kind of area could be perfect for traditional orthophoto. Here we can see again some mistakes because of the high building, but we blur the orthophoto nicely together. Another hard detail, so big hole, but in this example, it's actually better than I thought. This is mainly because we fly high enough in this case. But nevertheless, you can see the resolution is almost perfect. It's the same to the resolution. It's the same to the resolution of image. And for that kind of areas, this is kind of a perfect approach for the traditional orthophoto. Okay. Let me now share my screen again with you. Zupan, can you see my screen? Can you just confirm it?
Yes.
Okay. Okay. Very good. So now I would like to show you another nice example for true orthophoto. So the second option of orthophoto. In this case, we need to fly this in a double grid mission or oblique mission in a DJI flying path planner. And you see we have a lot of side images which are pointing in the center of the object, a lot of buildings on our area of interest. I assume the traditional orthophoto would not be successful here. And if I go and switch to the orthophoto, here you can see now the roof positions are actually on the right spots. What's the bit problematic part a bit with not the perfect 3D mesh? We also have some artifacts close to the roof edges. Of course, we are also working on that to improve it in the next versions and so on. But nevertheless, it's still much better in case you use the traditional orthophoto here. So this is my second example that you can have idea. And then I have additionally prepare you a traditional true orthophoto with our favorite example. And if I go here to orthophoto, I actually have both of them on. So now I select the traditional orthophoto. The problem of, sorry, let's do it like so. The problem of this example was I was flying pretty low. So I didn't fly on 80 meters. I fly here actually on 40 meters. And I have here a big long object. And of course, the complete object is not on actually on a single image. So as you can see it here, my single image doesn't cover the complete object here. And then when we blend those things together, we get that kind of effect with traditional orthophoto. That's why we recommend you, if you are in city centers, use the true orthophoto. You get the position of the roof on the right location. And the complete building is nice. So actually the roof is on the right position. So if I compare this with traditional one, you see, so this is the wrong position of the roof. This is the right position of the roof. And again, here maybe even more visible. So this is the traditional orthophoto. This is true orthophoto. Traditional orthophoto, true orthophoto. And the higher are the buildings, the more visible is this effect. Okay, here even more maybe. Okay, even here where we have walls, you see, this is not perfectly perpendicular. This is perfectly perpendicular. But with the traditional orthophoto, instead you get maybe a better resolution. So if I focus here on the manhole details, okay, here is actually true orthophoto better. Not sure why. Shouldn't be. So this is the true orthophoto. This is the traditional orthophoto. So maybe you can see a bit more from the traditional here. And just to remember, where you decide where you find the traditional and true orthophoto. So after you go to the orthophoto, calculate top down, you see here written if this mesh, this source gives you a true orthophoto or gives you traditional orthophoto. Okay, so in practice, if you have as a mesh a regular grid mesh, we will suggest you actually a traditional orthophoto. If you have a full 3D mesh, the 3Dsurvey will suggest you here true orthophoto. Okay, I spent quite a lot of time for explaining this. Mattia, would you like to add something, or can we go?
Yes. Let me share another of mine example, if
Okay.
may. So I also have an example that compares the two orthophoto modes. So yes, here it is. This is the true and traditional orthophoto. There's a couple of advantages of traditional orthophoto here. Because the traditional orthophoto is built on a mesh on the DSM, as Marco mentioned, it will cover the area that the DSM is covering. So sometimes, usually where there's some vegetation, a point cloud can be quite sparse, and as a result, so can the full 3D mesh. And in such cases, traditional orthophoto can perform better. If you look at this road here, on true orthophoto, it got cut off because the point cloud here was too sparse and full 3D mesh was not generated well enough. This is on the edge of our case, so it's not really that important, but nonetheless, this can be a bit of an issue sometimes. The other thing where traditional orthophoto is better is if we zoom in on these trees, they don't look so good in the true orthophoto, but now I will turn on the traditional one and we'll be able to see these nice canopies and all the branches, everything in detail. It gets problematic when you see some sort of cables like this, because as Marco mentioned, stuff on height is not on the right. It's not on the right position. So this is one thing. And the other thing that I would like to explain here is the recalculate tool. So as you heard, when you are able to capture a whole house or an object on one image, you can also use traditional orthophoto for houses. You can see here, this isn't perfect. That's because this house is comprised out of two images. Now I can simply repair this issue, but that's only on the traditional orthophoto. So I have my traditional orthophoto, select the area of the house, and software will automatically offer the substitute image, and I will choose this one where this house is nicely visible on one image. I confirm, and all I have to do now is recalculate orthophoto with this button and observe this image is replaced now. The whole orthophoto image will be stitched together once again. Well, just the blending between this image and the neighboring image. This is taking a bit longer than expected. Should be done soon.
What's important also here is that you actually select a bit of buffer zone around the buildings, as Mattia did.
Yeah. So now you can see these perfect edges of the roof. It may not be on the exact right coordinates because it's still on the height of the terrain, not on the actual height of the roof, but it looks nice. If you only need an image, that's what you can do. So that's my part on the orthophotos.